Welcome back, folks. So for this video, I'm going to go through a very brief introduction to UI. This is Universal Introduction. In other words, this is moving from some particular item, we don't know what it is, to the claim that for all of x, x is that particular item. So this one does have some limitations. But let's go ahead and start with something that is not a limitation. And it's also going to require us to use UE. So let's go back to our example earlier, where we had, for all of x, if x is a duck, then x is a bird. That's an assumption. Let's say that we had an additional assumption. Let's say we had an assumption that said that everything is actually a duck. Note here that we have two universals. However, our rule for UE allows us to introduce any small letter, and by small letter, I mean A through W, anytime we use UE. So even though we have two universal statements, we'll be able to use UE on both of them and make those x's into whatever we want, as long as we're being consistent. Now, let's say that our goal is to show that everything must then be a bird. To understand this, let's draw our universe again. So here's our universe. Within our universe, we had the bird box. And within that, we had a duck box. Our first premise, right here, captures the relationship between these two boxes, namely the duck box and the bird box. Our second premise, however, we can represent by shading in the duck box. It turns out that for everything that's actually in the world, everything is a duck. So, can we prove that everything then must necessarily be a bird? Well, yes, and here's how. For line 3, we would first take line 1, make it into, let's say, DA arrow BA, 1 UE. For line 4, we would want to take line 2 and make that into DA. Note that what I've done is I've replaced the X with the same little small letter, the same particular letter, an A. I could have also used a B, a C, a D, etc., as long as I'm being consistent. That's 2 UE. And now, for line 5, I'm allowed to use the same rules that I've always been using so far in this class, in this case, modus ponens. Via modus ponens, from 3 and 4, I can get BA. Now, the question, though, is am I allowed to move from BA to XBX? And the answer is yes. I can use, with line 5, UI. But why? Well, in this case, let's go over to our picture right here. We know that premise 1 says that for everything, if it is a duck, then it must be a bird. We also know that premise 2 has stipulated that everything in the universe is actually a duck. And we can see that the duck box is nested inside of the bird box. So if everything in the world is actually in here, then necessarily everything must also be a bird. Now, there are some limitations on this. The limitations are, well, let me give a quick example. Let's say that I start off with a particular. Let's have tall. Let's say that Alex is tall, and that's going to be our assumption. Am I allowed to move from this particular to the claim that everything is tall? No. Why? Well, let's consider a universe. And let's have a tall box. And let's have a short box. Now, Alex is over here in the tall box. Let's say that they're joined by a number of other people. However, over here in the short box, there's also some people too. You can't be in two places at once. So F, G, H, me. I'm definitely over here in this box. So the fact that we know about some particular item, in this case, Alex being tall, it doesn't actually tell us necessarily that everybody must be tall. This is a possible world. It says this is a possible world in which premise 1 can be true. Namely, it is true that Alex is tall. But premise 2 is false because, hey, there are some people who are not tall, this is an invalid inference. And being an invalid inference is the type of inference that we don't want to make. So this is one of the limitations on UI. We can't move only from a particular or a particular that we have already assumed to a universal statement like this. There is room some of the time to move in tandem with something that is a universal claim. But that'll be pretty rare. So in this video, what I did is I briefly introduced you to universal introduction. Namely, this is what allows us to move from a particular to a universal claim, but only in certain circumstances. In this case, note that the particulars came from universal claims themselves. In contrast, an attempt to move straight from a particular to a universal without any other additional information or universals isn't a valid inference, and isn't something that we should be doing.